Hi, we are now going to talk about kinetic energy, which I'm sure you probably know has to do with motion. So, kinetic energy is based on moving objects. So, anything that's moving should have kinetic energy, which means that if it then hits anything, it should be able to transfer some of that energy from itself to the thing it hits, right? So, let's get right into it here. We are going to abbreviate kinetic energy with a KE, okay? And we always use this formula. We're saying it's equal to one half times the mass times the velocity of the object squared. Okay, where I'll just write this out. M equals mass and V equals velocity. Okay, now let's go through this again. Kinetic energy is going to have the unit of joules. Okay, so it's going to be one half times what's the unit for mass kilograms. We actually don't need the one half in this case. Kilograms times what's velocity's units, meters per second squared, right? So that would make this side kilograms meters squared per second squared. And if you remember that a joule is a Newton meter and that a Newton is a kilogram meter per second squared, we then have we have kilogram meters per second squared times meters, which is equal to kilogram meter squared per second squared. So that's why we need to use the correct units when we're doing this. So please, for mass, you need to use kilograms, and for velocity, you need to use meters per second. Okay, so we'll put mass in kilograms and velocity in meters per second. So frequently, this is given to you in the correct units. I'm not really in the business of trying to punish you for not remembering how to do metric conversion, but I will be asking you to convert mass occasionally into kilograms because that's at least easy enough. Okay. So let's do our very first problem right here. Okay. So let's say that we have an object, or let's say it's a car, right? And the car is moving with a constant velocity, and that velocity is, I don't know, 10 meters per second. That's not horribly fast, right? And we'll say that the mass of the car is 100 kilograms, right? So we are looking for the kinetic energy, right? So all we have to do is plug stuff in. So let's switch colors. We know that kinetic energy is equal to one half times m times v squared. So now we just plug stuff in. One half times 100 kilograms times 10 meters per second squared, right? Which is equal to one half times 100 kilograms times what's 10 squared? 100. And we squared meters and we squared per second. So per second squared, like this. Okay. So what's 100 times 100? It's 10,000, right? Divided by 2 is 5,000. So 5,000 kilogram meter squared per second squared, which is joules. And then bada boom, bada bing, we found how much kinetic energy we have. Easy peasy, right? Okay, let's go to the next page and try it again, right? So we're going to write the formula at the top. Ke equals one half mv squared, right? Now, let's say that I tell you that the total energy in a moving, let's say it's a skydiving person, the total energy equals 2,500 joules. Okay. And then I tell you the mass of our human being is, I don't know what a mass is in kilograms. I don't know, 70 kilograms. I have no idea if that's a reasonable mass for a person. I'm sorry. Okay. So what we're looking for is velocity, right? So let's plug in what we know. We know that 2,500 joules, bear with me for a second while my computer lags, equals one half times 70 kilograms, right? Times v squared. So we need to solve for v squared, right? So in order to do that, let's make this easy for ourselves. 2,500 joules equals 70 divided by 2 is 45. 45 kilograms times v squared. So in order to get v on its own, we divide by 45 kilograms, right? The kilograms cancel out here, the 45s cancel out here. So you're left with v squared equals 2,500 divided by, holy crap, 45 kilograms. Okay. So I'm doing this on my calculator really quick. 2,500 divided by 45 is 55.555555. 55.5 repeated. And what's the unit for that? We don't know yet. It's joules per kilogram, right? And remember that a joule is a Newton meter and that a Newton is a kilogram meters per second. So a joule is a kilogram meter per second squared, meter squared per second squared. So that means we did kilograms meter squared per second squared divided by kilograms. So we canceled kilograms. So we're looking at meters squared per second squared, right? So if we simplify this units situation, and if you're confused about this, just ask me and I'll help you out. Okay. So meters squared per second squared, which makes sense because we're looking at velocity squared, and velocity is in the unit of meters per second, right? So if you square velocity, you better have meters squared per second squared. So that makes sense. So all we need to do to find velocity is, in fact, I'm going to do this in a different color. We need to take the square root of both sides, y'all. Square root of velocity squared, square root of 0.5 or 55.5 meters squared per second squared. So we're just going to find our square root button and we're going to press it. Okay, so square root of 55.5 is good enough. Okay. So if we take that, it's going to end up giving us 7.45 meters per second equals our velocity. And then that's how fast our object must be going. Okay. So that's how fast you're moving if you're skydiving and you're moving at a constant speed in this problem. Okay. So that's how you use kinetic energy problems to get from one place to the other. What you may be realizing now is that you've seen kinetic energy and you've seen potential energy. So kinetic energy and gravitational potential energy are closely related. You actually, if you have one of them, you can find the other one almost always, right? And we're going to talk about this. It's going to be called the law of conservation of energy, or rather conservation of energy, right? Energy in a system should stay the same. So if we're in a system and we have some GPE, we should be able to calculate how much KE we have, or we should be able to calculate how much KE we will have if the object starts moving. So that's going to be what we do next time. That's a wrap on today. Good luck on the problems.